Unit E, linear regression. There will be three sections to this piece: explanatory and response variables, displaying the relationships, and then measuring linear association. So if we took a look at this from a 10,000 foot view, we get this graphic. So section 1 talks about explanatory and response variables. In terms of algebra, the explanatory variable would be the x variable. The response would be the y variable. So in stats we use the word specifically explanatory and response because we're looking for a variable that we would consider being the reason things are changing. So the variable that explains what's happening in terms of the response variable. So the response variable is the y. It reacts to the x. So on a graph right here, section 1a will talk about what variable goes on the x-axis and what will go on the y-axis. In section 1b, we'll talk about creating that graph. So we will have a scatter plot that represents like one person. For example, one person that would be this far over and this far up would get a data point in terms of the two variables that describes that person. And you get a lot of people together and you start to get this distribution of data points. So the way we create that scatter plot will be using this on StatKey. We'll get to confidence intervals and hypothesis testing at another time, but right now we're just talking about creating the scatter plot, so we will use that link, two quantitative variables. So when you create that graph, 1b then shows you how to do that, but it also describes how you would describe them. And 1b looks at two of the three ways we can describe that relationship. The first is, does it look like a linear or nonlinear path? So when you look at this data, it seems to be going down and to the right. Okay, so how do you describe that? Well, does it look like it's a straight path, or does it look like it's curved? So you're going to use words like linear or nonlinear. You also talk about direction, and this is where it relates to slope, but the only part that relates to slope. In other words, is it the positive slope or is it negative slope? In this case, this would be a negative slope. Whereas if I had data that was going up and to the right, that would be a positive slope. In other words, a positive direction. 1c goes further and talks about its strength. So the strength of the data is referring to how close the data is to a line. So in our first example here, we have the data. It's kind of around this green line. We'll talk about how to create that line later, but it's not on the line, but it seems around it. So it seems like it's going on a path, so it has some strength. If we were to put it in perspective, it's called the correlation coefficient, and it has a value from -1 to +1. And we'll talk about what that looks like in a moment. So let's go to an example here. And it talks about, we know that cars and trucks lose value the more they are driven. Can we predict the price of a used Ford F-150 if we know how many miles it has on the odometer? Now, the way they state that is very important. Can we predict the price if we know how many miles it has on the odometer? So in other words, it's telling us that how many miles on it is the explanatory variable, and if we know that, we can then predict the price. So that's the response variable. So in other words, this is the explanatory, miles would be, and price is the response. So if you go down to the graphing of it, you would put, dollar amount on the y-axis and miles on the x-axis. Now, for efficiency's sake, this has already been graphed, and we would have used StatKey for this. But if you look at this data, and we're going to describe it, and we look at the form and direction first, does the form seem linear? Again, we'll talk about lines later in creating those lines, but it seems like this is going down and to the right. It seems to be a path that's straight, so we would describe this as, yes, linear. The direction is negative, okay? Now, the last piece to that is a correlation value. And as I mentioned earlier, correlation coefficient is a number between -1 and 1. Now, these are the extreme examples. Notice that the data in this right here is a perfect line. There's no variation whatsoever. It's negative slope, so it has a -1 correlation coefficient. Whereas this one over here is a positive slope, and again, all in a straight line, so it's a +1, a perfect correlation. This right here is scattered, right? Definitely a scatter plot, but there's no direction, right? It's just a scattering of data points, so it has zero correlation. As one variable changes, you can't really tell or predict what's going to happen to the other variable. And we want to come up with a number that is basically between -1 and 1 that we feel describes this picture. So you know it's negative, so it's probably going to be between -1 and 0. And you're probably looking at something maybe about 0.5, maybe some -0.5, excuse me, or closer to -1, because it does seem pretty tight in how it fits here. And that value we will learn how to calculate as well in the future.